So this is another question, another audience question. I noticed that in June 16, 2020, patient's length of stay, the project statement explicitly said to interpret the original GLM and not the Lasso GLM. My question is as follows. If we binarize data and run Lasso, we will drop some feature levels. An example from this exam was only a few age buckets were included as significant, and the other binarized variables were dropped. Let's say, 0 to 20, 20 to 40, and so forth. But if we ultimately use this GLM as a final model and go to interpret the coefficients for Poisson with log link, it is appropriate to say the base level for the intercept is any age that is not specifically included in the model. For example, 40 to 50, 50 to 60, 70 to 80. For example, if age bucket is 0 to 20 and there is a multiplicative impact in the intercept of X beta. First of all, this is a really good question because it demonstrates that you understand a lot of things. You understand the GLM, the lasso, binarization, variable interactions, and also binning, which is when you put the variable into bins. So the easiest way to explain this would just be to look at a little example. So let's say you had, age, and this is like just a number. So for each person, this is Bob, this is Sam, this is Sue, this is Mary. You know what their age is. And when you create the indicator variables, you're going to say, a new variable, which is age 10, age 30, age, let's just keep it at 2. So for this person, it's 1 and then 0. And then for this person, it's 0, oops, and then 1, right? And so, so first of all, you create these binary values, but you know that if you put, so let's say you fit like a linear model that was just, Y follows age 10, right? So that will only need 2 coefficients. It will have the intercept, beta 0 plus beta 1 x1, and this is x1, so it's beta 1 times age 10. So this will just be 0 or 1. So like if the reference level, if the base factor level for this age 10 value is 0, that would be people who aren't age 10, then this will not make an impact, except when the person is age 10, then there would be the coefficient added. But when you do binning, you're actually doing something even more complicated. So like, let's say you're creating bins like age 10 to 20, age 20 to 30, age 30 to 40. So this is 1, 0s. This is all 0s, 1, 0. This one 30 to 40. We'll have to assume that this is like, not inclusive of 30. Okay, so now you'd have these variables. So you could fit a model like this. Y is age 20, 10 to 20 plus age 20 to 30 plus age 30 to 40. And these variables would be binary predictor variables. So each one of them would have a base level, which would either be 0 or 1. It would most likely be 0 because that's where the, most people are not going to be in that bucket. And so then if you fit a lasso, you might get like a simpler result. So like, let's say this is your model. And then after lasso, you remove this first one. So then you just have this model. So it's just age 20 to 30, age 30 to 40. And so at that point, if a person isn't in age 20 or 30 or in age 30 to 40, then you can infer that they have to be in age 0 to 10 or 40 plus, right? So that would be the reference level. So yeah, so ideally, your reference level is always going to be the one that has the most observations. But if the project statement tells you to use a specific algorithm or to do things in certain steps like this, then you just have to follow what the project statement's telling you to do. Let me just stop the screen share so I can read the chat. Okay. Thanks. Can you please also explain log and identity? Yeah. So log link function is, log, let me see. Log link function, identity is the easiest. Identity just says that the mean of your target is your linear predictor. So let's see if I can do this. Screen share. Whiteboard. So for identity, you just say that y is equal to beta 0 plus beta 1 x1. And so like, let's say your family is gamma, and your link is just identity I, then it means that you have, for each person, you have a gamma distribution, and the mean of that gamma right here is just equal to that, beta 0 plus beta 1 x1. And then for log, if you had, so if you have a log link, then it means that your mean, the log of the mean is equal to beta 0 plus beta 1 x1. So therefore, if you take the exponent of both sides, the mean is the exponent beta 1 x1. So does that make sense? Is that answering your question? So to interpret, your coefficients, let's say you had, x1, x2. Oh no, let me. I think that answers your question. Let me know in the chat if that doesn't, because we've seen a lot of those examples. We've seen a lot of interpretations of log link functions. You can just look at some of the old practice exams. I think so. Oh, can you explain the canonical link? Is the logit function the only canonical link? No. So the canonical link function comes from the GLM theory. I don't remember the formula right now, but there's this screen share. There's this formula that every distribution that you use comes from the exponential family, which means that the PDF can be written using a specific formula. It's like, like a PDF is a probability density function. Like for the, a binomial, the PDF is like n choose k, x to the n 1 minus x to the n minus k. That's the PDF. And when you're working with an exponential distribution, it's like the gamma, the inverse gamma, the Gaussian, the binomial. It means that you can write it using like this function of exponentials. It's like e to the a of x plus b of, x times c or something like that. I'm just making up that formula. And then each of these components, a, b, and c, when they're set to different values, results in different distributions. Like if you set this part to 0, you just get an exponential random variable, And the canonical link function is the mathematical. So it's the most convenient way of choosing these values. So depending on the family. So like it's basically theoretical, but the theory helps the algorithm to converge most often. So it makes your modeling faster to fit. Like if you look at the GLM output, it will tell you the number of iterations that it took to converge. And when you use the canonical link, often it will be faster when you use that. But it's not a requirement. In data science, the best model is the one that works the best. So you use it as info, but don't make all of your decisions based on it. Always look at the training error and the testing error, the AIC and the BIC. Is the logit function the only canonical link? No. So like different families have different canonical links. In R, if you type in GLM or family, it will show you the link functions for each family. Like for gamma, it's the log link. For Gaussian, it's the identity link. For logit, it's the log odds. For the binomial family, it's the logit link, and so forth. Let me know if you have other questions. I'm just going to keep moving on here. We do have more. Yeah, I was just going to talk about model selection. No, what was this slide? Okay, well, let's just finish up this question. So my question was, we did 3 things. First, we put the age variable into bins, and then we binarized each of the bin values. So we added dummy columns or indicator columns. And then you used a lasso, or you could use stepwise selection in order to remove some bins that are not significant. If we ultimately use this GLM as the final model and go to interpret the coefficients for Poisson with log link, is it appropriate to say the base level is the intercept of any age that is not specifically included in the model? I wouldn't say that. That's kind of a big leap. I would just explain your process step by step. Yeah, so that is, so does anyone else have any other questions right now? Or would you like me to go through, other examples? Like I could go through that, I can go through examples from our latest exams, or I could, just open up a practice exam and start working. We did book this webinar for another hour, and I'm just, so I'll just keep going. Okay, how about I will just go through one of our practice exams. I'm just going to show you how I would conduct a practice test if I were retaking this exam. So I'll go to our formulas, our folder. All right, let's do this bike sharing demand exam. So first of all, I just need the template files. So just make a copy of this. And that's not working because it's making a copy. Okay, we're going to try a different one. You do have another question. Okay. In one of the practice tests, hours were handled as numeric. I decided in my answer to make them factors. Is there a good guideline on when to make something numeric or factor? Yes, there is. If you can compare the two values, like if you can measure the thing, like let's say you're looking at, well, let me say that again. So when should you make a variable numeric and when should you make it a factor? Well, that question is context specific because it's asking you about for a decision tree versus for a GLM. But in general, if the variable is a number, like it's something you're measuring, then it should be a number in like a numeric type. If it's like a category, like let's say it's weekday and they've coded the values, Sunday is equal to 1, Monday is equal to 2, obviously that should be a category. And even better, you can rename the variable levels to be 1 is equal to Sunday, 2 is equal to Monday. So when you fit your GLM, it's easier to read. If you do like bin the variable, then you can make it a factor. Like in the age example from earlier, you're going to have different bins for age 1, age 10 to 20, and so forth. The reason that we do that is because it can reduce the likelihood of overfitting. And like in insurance pricing, for instance, you typically would just include bins for ranges of the variable that have a lot of observations. Like if you're modeling patients and everyone is, between, 18 to 65, and you only have a few people who are between 18 to 30, you could just put all of them into one bin. So the reason why they do that is because it allows you to interpret the result using relativities or when you take a log link for a GLM, you can just look at the exponent of the coefficients and then break that down into just a bunch of numbers that are multiplied together. So that just makes a very simple list of rules. So you can say, oh, you're a minor, so that's plus $100 per member per month in your premiums. Oh, you're over 65, that means you have to pay this amount more, each month. So to summarize, there's no single guideline. It depends on the question, what they're asking. In your opinion, do you think the new SOA changes related to R code will really cut back on the amount of code they provide? What areas do you think we should definitely memorize related to R code? I would say just look over the modules. Look over the SOA's modules. See if I can just open that right now. I don't remember. So just look over the modules and look at the sort of the snippets that they provide to you, which are always the same for the practice exams. Like you'll notice that when you're doing like data visualization, they're going to give you like all the ggplot things, to create like the big like facet of like they show you like all the histograms and all of the line plots and things. Like when they have a for loop, you don't have to worry about that. They're not going to make you write anything in a for loop. They're also not going to expect you to know dplyr. So anywhere you see these, the pipe operators, you don't need to learn that. But like when you're doing like data manipulation, like adding variables, removing variables, filtering out observations, you should be able to do all of that from scratch. And from scratch, I mean by using their template code. So a good exercise to do is our data prep exercise. You go through that and try to just use their code snippets. So I forget where this is. It's in like week 4. Data exploration right here. So you don't have to use the code that I give here. You can just use this as a starting point and copy and paste in the code from like another practice exam when you're like creating these graphs or making changes. So this part is the exercise. This is just the lesson. This is the actual sort of exercise, and then you can compare the result. And when you compare the result, don't try to match everything verbatim, because there are other ways that you could explain things. You could use a line graph, you could use a scatter plot, or you could use in some cases, you could use a different type of graph, or you could just look at summary statistics or use an Excel table. Sometimes you don't even need to use a graph. Should we automatically transform all character variables to factors? Yes, that's my personal opinion. But don't just break the code. If you see that they do something in the template, just kind of leave it, because they'll probably fix it later on. So if you just make a change at the beginning, you might have to go through and make that same change like a million different times. So just, don't make a change unless they sort of tell you to. And should we re-level at the beginning of the exam if we see that there is a GLM question later? Or even if they don't explicitly tell us to do this? I would say no. If they don't tell you to do it, don't do it. Because you could spend time, re-leveling, and then they tell you to drop that variable altogether, and you just wasted your time. But it's good that you can write that. So even if you don't do something, you can say in your report, oh, by the way, I know that I should have re-leveled these variables, but the project statement didn't tell me to. Because you can just write to the exam grading team. Unless they tell you to write to the audience, you're just writing to the grader. You're just writing an email to the actuary who's grading your exam. In one of the practice tests, hours are handled as numeric. I decided on my answers to make them factors. Okay. Is it a good guideline on when to make something a numeric or factor? We already answered that question. In your opinion, do you think the new SOA changes related to our code will really cut back on the amount? We already answered that question too. If we don't know the answer to a question with the exam being graded relative to other test takers, is it better to try a BS an answer and leave it blank? Or how do you think we should approach that? Definitely don't leave anything blank. At the same time, you're not graded based on the number of words that you write. You're graded based on how well you answer their questions. So you can have a shorter answer that gives them everything that they want. So I would say just do your best and explain your process. Like, let's just imagine that I took the exam and I completely forgot what the difference was between bagging and boosting. And the question said, explain the difference between bagging and boosting. I would just try to write everything that I know. Like, I know that random forests use bagging, and I know that GBMs use boosting. And I could say, oh, well, a random forest has fewer hyperparameters. It only has entry and mtry parameters. whereas a GBM has more parameters like the learning rate, the number of trees, the subsample percentage, et cetera, et cetera. And so you could say, oh, one difference between bagging and boosting models is that in random forests, aka bagged models, there are fewer parameters. And that's not wrong. It's just not complete, right? So I would at least get like 1 point on that. Well, and also just kind of leave it empty and then keep going through the exam. And you might refresh your mind when you get to the end. They might even give you a free cookie at the end. They say, oh, this is the difference between bagging and boosting, in the end of the exam, that you can just use that earlier. Will we ever have to calculate or interpreting the entropy for a decision tree? And if so, how do we go about doing that? Great question. Yeah, we do. In the SOA modules, they do have this really complicated example where they make you calculate it. I remember doing that. I don't expect that it would be that difficult on the real exam. If they did ask you, I think it would be more of, fit a decision tree that uses Gini, and then fit a decision tree that uses entropy, and then, explain what some of the differences are. The answer is you basically need to fit both models and see which ones performs the best. And what you don't use as a splitting criteria is the accuracy, because that's it's not sensitive enough to decide on which splits are good and which splits are bad. So if you look at our trees lesson video, I do go through a simple example like this. So to sort of summarize, I won't even summarize this because I don't want to take up time. You can just watch this video and see how to calculate the Gini and the entropy for a tree. What are your thoughts on making edits, if asked, to the data in Excel if I'm really struggling with making the changes in R? I remember that, Tom. I do remember you're asking me that question. Do you think the SOA would greatly penalize this? My thought is at least it would allow me to do the modeling and perhaps still pass. I don't think so, simply because it's part of what they're testing. They expect you to learn R, and so that's what they want you to do. If you did use Excel, you wouldn't have a way of it being graded. You'd have to go into Excel, make the changes, and then export as a CSV file, and then import the CSV file into R. But CSV files don't have any way of showing like the steps involved. So the grader would just look at your data and just think that you just didn't do anything. And they also wouldn't be able to reproduce it. When they do grade your exam, they're going to run your RMD file from beginning to end, and they're going to expect that the outputs will match what you pasted into your report. So you can't cheat by just making up numbers on your report, or they would catch that. So the good news is that we do have a lot of practice for the data manipulation. So if you just look on like that exercise I showed earlier, that will help you. Yeah, and if you do feel like there's absolutely no way that I can pass if I'm taking the exam this time, that's okay, because they're going to give you feedback. They tell you which areas you did well on. They tell you, okay, you did well on, you got like 4 out of 5 points on data prep. You got 5 out of 5 points on modeling, 5 out of 5 on selection, and so that when you retake the exam, you know what you need to focus on. So yeah, I would say just go for it. Do the best that you can, and it will just help you become more familiar with the material. And you've also already paid for it, right? So it's $1,200. Doesn't make sense to just throw that away. If you had to guess, and I know this is really a stretch, is dependent on a lot of factors, how many points do you think it takes to score a 6 on the upcoming exam? I think if you're asking that question, you should just be focusing on studying, because that's a moving target. If everyone on the exam scored a 90, then the pass mark would be a 95, right? The points are arbitrary. They want the pass rate to stay consistent. They're not grading it based on the number of points. I'm obviously going to try my best. Yes, try your best. Absolutely. Give it the best try that you can. As Yoda would say, do or do not. There is no try. So don't even say that you're going to try. Say that you're going to pass, right? Have that positive affirmation and then go do it. And if you need to, and you are going to pass, right? You're not going to, maybe you won't pass this time, but you'll pass next time. Thank you. Write something like time. Where the 24 hour is not, wait, I'm sorry. This is a kind of, thank you, right. For something like time, where the 24th hour is not 24 times the first hour. Oh, I think are you talking about factor variables versus numeric variables? In that case, yes. Like, let's say your input is time. It's like bins, like 1 a.m. to 3 a.m. 1, 4 a.m. to 6 a.m. 2. It would be better if you kept that as a factor. I agree. How do you expect questions to be set up with the summary being within the question? Will there be a way for bullets telling you what to do, and anything the last bullet would say something like summarize the first 3 bullets in a non-technical way? That's a good question. And yes, that's a very good example. They might ask you to do something and then have you summarize it. And I think it was the one of the 2020 exams, they say, summarize the data for your actuarial manager in like task 3. So in task 1 and 2, you went through and you create some histograms and cleaned the data, removed some records, maybe applied a log transform, and then summarize it using non-technical language. So you'd say like, we wanted to be completely sure that our data was free of any irregularities or errors. We looked at the data, we looked at both visual summaries and statistics in order to ensure that we were looking at every dimension possible. And then like, here's a very simple graph, that shows the distribution of the target variable. And you might show like a simple histogram, make sure that you add a lot of labels, make it very easy to read. And then, just now write as if you were writing, to a sales manager. And bullet points are great, by the way. Yeah, bullet points, that's faster to read, and it helps the grader. Like Howard was saying, he grades a lot of academic papers and a lot of academic tests, and he likes to see organization. So you can use like subheadings where you like make one heading bold and then, put a little paragraph and then another subheading and then like bullet points. Yes, that's great. If a question says to explain loadings on PCA or create a GLM and evaluate it, should I explain what a PCA or GLM is, or just answer what's asked? I honestly struggle with this too, because sometimes I do explain things when I don't really need to. I think that's because I'm sort of just in a teaching mindset. So I just sort of look at everything and say, oh, I need to explain this. I need to explain this because I'm creating tutorial videos. But you are not. You're just answering what the question says. It's always good if you can show that you know something, because even if you're wrong, you can still get partial credit for it. Like if you ask me, okay, fit a PCA to this data, and then choose and then tell me what the best principal component is, and I'll say A. A is the answer, and then I grade that and say no, it's B. 0 points. Whereas if you say, oh, well, principal component analysis is a dimensionality reduction technique where you take an original set of variables and transform it into a new dimension, thus removing variables, or thus combining variables that are highly correlated into a new principal component where the loadings or weights of each principal component give you a recipe so that you can take the initial variables and then translate them into the new coordinate space. Like if you say that and then say, oh, by the way, the answer is B. Oh, that was wrong, but you still got partial credit for the first explanation. So it's sort of a way of just padding your answers. Next question. I have trouble identifying interactions for box plots. Can you give me more guidance? Something the box plot looks similar, but the solution says there is an interaction. It is hard to tell. Yeah, it is. Let's just try drawing a picture. You don't need to look at a box plot, by the way. Box plots are just what the SOA happened to use in like the June exams. And so that's what we've sort of copied. You can also look at like facets. So here's the cheat sheets. So like here, so, if you have numeric, so what type of box plot are you talking? So let me rephrase that. So when you're looking at a factor and a factor interaction, then a box plot is useful, but you could also look at just a lot of histograms. Like, let's say, how do I clear this? There it is. Like you're looking at two variables, okay? Day or night, and then hot or cold. Okay, so you could just look at the all the combinations. So you day, cold, day, night. And that's not right. That doesn't even make sense. Day, hot. Night, hot, cold, hot. And then let's say you're just looking at the histograms, and this will be no interaction, and this will be yes. So if there was no interaction, then only one variable would make a difference. So it'd just be day. So it'd just be so when it's daylight, you'd have this distribution. These would both be the same. And then when it's night, you might have like this distribution. And if there was an interaction, then you'd have different distributions for each one. Like this will look like this will look like that, this will look like that, this will look like that, right? So it's just a way of looking at the dimensions. And does that answer? I think that answers your question. When you look at the box plot, it's just another way of showing you the distribution. So in R, the way you can do that is using facet wrap. So you do like geom histogram and then facet wrap. Var is equal to day and night. Because I think in facet you can use multiple variables. You can do like facet wrap day, comma, night. I know I should never take a log transform of the target variable, but I recall reading an SOA solution For the first couple of tasks on data exploration, they compared the log of the target to the predictor variables. Do you recommend doing this? Yeah, I know. I do remember that. I think it's in the traffic safety exam from the PA June 2019. The target is like crash score, which is a continuous positive value. And when they're looking at the histogram, they say this is right skewed. But when we apply the log transform, you can see that the graph straightens out. And they just do that to the histogram. Then when you fit the GLM, they use a log link function on the untransformed variable. But what you don't want to do is transform something, using an inferior method. That using a log transform is what you used to do before you knew what a GLM was. Before you knew that you had a log link function where you could relate your linear predictor to your target using that additional function, you used to rely on the primitive version of just transforming the target. And also there's an example in one of the late exams where you transform the output of a decision tree. I think that was in the either pedestrian activity or bike sharing, where they ask you to look at the square root transform, the square transform, the log transform, and the way that you choose that is you just look at the histograms and you choose the one that makes the distribution more symmetric. That's because in a decision tree, when you get to the end leaf node, you end up taking an average of all the values in a bucket. So if your variable is very skewed, taking a mean is sensitive to the skewness. So the mean will be skewed in the same way that the data is. So when you apply the transform to the data and then fit the decision tree and then take the mean at each of the leaf nodes, the predictions are better. Can you go over how to interpret PCA loadings or just how to read a biplot? Yes, I can do that. So we do have this example from the cheat sheet. So so the way to read this is that A and B. So here you see PC1 and PC2. So if you were so the way that this was created was you had data like this. You had A, B, C, D. Oops. So these are just numbers. And then you wanted to go from, so then you would run PCA and you get 4 PCs. PC1, PC2, PC3, PC4. And these would also just be numbers, except they would be their principal components, so that there'll be linear combinations of A, B, C, and D. And if you want to reduce the dimension, you can just choose like the first 2, or you could choose the first 3, right? So so that's what these are. So like, let's say that these vectors E and A were on almost, what's the word for it? Not adjacent, or they're completely uncorrelated, or orthogonal. Now, orthogonal is 90 degrees. I'm not sure what the word is for that. So it would be like negative. So like E is almost equal to like negative A. Then, that would be like, oh, there's an E here. Then there's like an E. This would be like approximately negative A. Or like, think of it in terms of like practical cases. If you're like talking about A being temperature and E being snowfall, you know that when the temperature is high, the snowfall is going to be low, and vice versa. So they have a negative correlation, right? So it would be something like that. And then B and C, these two, so green and red would be orthogonal. So that means they would be uncorrelated. So let's say your snowfall and the amount of coffee that I drank that morning, right? There's just no relationship between them. And then D and B would be like, the red and the yellow. These would be like positively correlated. Like, let's say it's you're looking at claims. It's, the person's age and their annual cost. As they get older, they are more expensive. Does that sort of answer your questions? I think we do have some examples of PC, of principal component analysis, in our exams. I want to say it's like the traffic safety exam. I think it's principal component analysis. If you look through our older exams and then look at the tags underneath the video solution, you can see, or you can just type in the search principal component analysis into our website, and it should bring up the practice exams that have that. Do you think quasi-Poisson or quasi-binomial distributions will ever be needed or appear? Great question. That is on the syllabus, although they have never appeared on the exam. So the way to test that is to look at the mean and the variance. If the mean, so for a Poisson distribution, remember you have one parameter, lambda, and lambda is equal to the mean and the variance. So if you look at your target's mean and your target's variance and they're radically different, then that means you need to use an over-dispersed Poisson, or rather the quasi-Poisson. And then for the binomial, you know that like the mean is just P, and the variance is P times 1 minus P, right? So you can just look at the mean and then take the mean times 1 minus the mean. And I think you should get to the variance. And if that doesn't work, then it means you need to use the quasi-binomial. And everything should be tested. You should have a training set and a test set. You should fit both models and then look at the performance, the AIC, the root mean squared error, the log likelihood, whatever it is that you're using. If yes, can you give a quick description of these and when they would be used? Yes, I can. I think there was actually an example. I'm trying to hunt it down, but I did like have a hypothetical answer where I was thinking, how could I do that? Let me see if I can find it. But it was for the pedestrian activity, right? Because you're counting the number of pedestrians in an hour. So you can try just fitting the quasi-Poisson to that data, just add another model and then look at the performance. Is the AIC better or worse? It's a good question. Should we rebalance classes if not asked to do so? So I summarize, rebalancing classes is because your classes are imbalanced, meaning that there's more in one class than another. Let's say you are modeling loan defaults, and most of your loans don't have most of your loans are fine. They're not going to default, and only like 10% of them are at a risk to default. If you just trained your model on that data, then the model will be good at identifying loans that are safe, but it won't have many examples of loans that are false. And so if you end up just training your model, it will just predict that all loans are safe. And so you need to use rebalancing. So the way that you do that is you can oversample the number of defaulting loans, or you can undersample the number of the safe loans. There's also another technique. It's not on this exam. It's called SMOTE, synthetically majority oversampling technique. I think that this exam just uses over and undersampling, and you use the caret library to do that. That's never appeared on an exam before, but what you do check is that the percentage of the mean target is the same in your training set and in your test set. So yeah, if they don't ask you to do it, I don't think it's necessary, but definitely comment on that. And when you get to fit your model, say that, or in the executive summary, there used to be a section where you talk about future considerations or next steps. If you have a question like that, where they can ask you, what would you do differently if you could repeat this analysis? And you are working on an imbalanced class, you could say we could rebalance the classes. Weights and offsets are the worst. I know you went over this in the apartments practice exam. Can you run through when to use an offset versus a weight? Yes, I wouldn't say that they're the worst. I would say that they can be confusing. But really, once you look at this, you'll see that it's actually very straightforward. So a weight is your measure of exposure. And an offset is just a constant term. How do I think about this? So like, you all know how to take like a weighted average. Like you have, your vector W, which is your weights, and your vector X. So like if you want to take the expected value of X, it's, the sum of weights times X over the sum of the weights. And for GLM, I'm just going to use a GLM example, but it actually applies to other types of models too. So the expected value, is the expected value of Y, which is your model, is, beta 0 plus beta 1, X1, which in model matrix term is just X times beta. Well, if you add weights, then you have like an X times W times beta. So it means that different observations get weighted differently. So let's say you're predicting insurance claims and you have different lengths of policy period in months. So your exposure is the number of months of the policy. You know that policies that are longer are going to have more claims. So that's your weight. So then what's an offset? So an offset is a way of forcing, it's a way of adding a linear term to the predicted, let me say that. An offset is just a constant that you add to your, it's a constant variable that you add to your linear predictor. So I'm trying to think of an example. This is a real example. So let's say that you're an actuary and you're fitting a model for life insurance. Let's say it's mortality. Let's just keep it at claims cost. And so you already have your predicted value. Like, let's say this is y hat 1. So this was like, some actuaries in 1990 created a model for predicting claim costs. And then you want to compare that to, your new model. Once you've added in new data, you're using a Lasso regression. You've done all this fancy feature engineering and so forth. So like let's say like Y1 was just really simple. It was just like, X1 plus X2. And then Y2 was, X1, X2, X3, X37. And you wanted to know, does this model improve upon this model? So rather than having to refit the whole model, you could just use this as a predictor into this model. So you'd say y is equal to beta 0 plus beta plus this is y2, y1 plus beta 1 x whatever 1 beta 2 x2 plus, right? So so this is just a constant term, or you can think about it as having a coefficient of 1. So if you were to look at this in a table, you'd see beta 0. Well, let's just say that this is person. Here's Bob. Here's Sarah. Here's Sam, right? The intercept is the same for all people. 1.5, 1.5, just some number. And then this is going to be different because this was the model that we fit in 1999. So this might be 37, 100, 99, and so forth. And then you have these. So you have the coefficient times that person's variable. So you have beta 1 times x1. So let's say Bob, so this might be different for each person. And all of these would be different for each person. But this coefficient is chosen based on the maximum likelihood. So these are actually, estimated. That's why they have this hat on them. Whereas this isn't estimated. It's treated as a constant. So that's the offset. So the reason why you use an offset in this case is so that you don't change everything that was done in 1990. You could just use those same that same model, and then fit the new model on top of it. So from a regulatory perspective, that can make it easier. You wouldn't have to get all of this new information past regulators, or you already know that it's working. It's already worked for 20 years. We'll just keep using that, and then we'll just try to improve upon it. So it is 2:53. So we do have 7 minutes left. If anyone has any other last minute questions, you just send them to me in an email. I am going to be online for the next week. If you have exams that you want graded, maybe you've answered a question in a new way, you've used a different type of model than what you've seen in our solutions, or you just want feedback. You want to know, am I doing this right? How could I improve? I gave myself a grade of 90 on this exam. Do you agree with that? Do you think that you would actually get a 90? I'll give you some feedback. If enough people send in their exams to be graded, I can even help to give you some comparisons. I'll keep everything anonymous, of course, but I'll be able to say, a lot of people seem to be having difficulty with hierarchical clustering. Here's some other resources that you can use. If you do and the other thing I would just say is just focus on, consistency. You don't need to be like you're not going to be able to learn everything. There's just not enough time, and it's better to focus on your routine of sitting down for 5 hours, waking up at the right time and just churning out words on the page, being able to type quickly. Those are the intangibles. Like in baseball, you'd say like a player is like an intangible asset because, they're going to always play in the game. They're not going to get injured. They're going to have a good eye. They'll get on base a lot of times, even if he's on a hot streak, even if he's hitting home runs, he'll still be an intangible asset. So just try to focus on your intangible assets, like, writing cleanly, not making grammatical mistakes. I said studying at the right time, using right formatting, making things in nice subheadings, using bold when you need to, and also your process. As you do practice exams, you'll just be able to know, oh, I'm spending too much time on this question. This is only a 5-point question. I've already spent 30 minutes. I really need to keep going. That's going to help you out a lot, regardless of what you see on the test. One other thing to note is that I think when the results come out, you will have a better idea of how you did because there's only one practice exam. There's only one version of this exam. In the past, there were two versions. And so when you looked online and on Reddit or Actuarial Outpost, you couldn't compare yourself to everyone, but now everyone's taking the same test. So don't let that sort of discourage you because, oftentimes, what people post online is misleading. Honestly, it's in my experience, it's the people who are posting online, they're sort of insecure, that want to get validation, or it's the people who like completely aced it, that studied 600 hours and they want to brag, so don't base your thought of how well you did, just based on that. So that is it for this webinar. Thank you for everyone for joining. Feel free to email me your follow-up questions. Best of luck on this exam. I know you're going to crush it because you're already on this webinar. You've already taken this course. You've already sat through all these lectures. You've already grinded out all of these practice exams. And you have everything that you need. You just got to go there and you just got to execute.